All right, boys and girls, welcome to our second video lesson in Chapter 5, our lessons on 5.3 and 5.5. Much of the material in these sections are stuff we've already learned, but now we're just going to make it official. So, here we go. Okay, first thing you already know about is the triangle in exterior angle theorem, which before we called the TIT. Okay, so this is the TIT, which of course stands for triangle exterior angle inequality theorem. And what it says, we already know that any exterior angle, such as measure of angle 1 there, is going to be greater than both measure of angle A and the measure of angle B, any remote exterior angle in the triangle. Okay? Okay, let's look at these problems right here. We got use the TIT, use the triangle exterior angle inequality theorem to list all the angles that satisfy the stated conditions. We first want to know all the angles that measure less than angle 7, which is right here. Notice that it is an exterior angle to two triangles, this triangle right here. And it's also an exterior angle to the big triangle right here. So therefore, measure of angle 7 must be larger than angle 1, angle 5, and angle 4. I should put a little angle sign there. So it's bigger than this angle, an exterior angle. It's bigger than 5. It's bigger than 4. It's also bigger than 4 and 2 put together, so therefore it also must be bigger than angle 2. Okay? Let's erase. Let's look at all the angles that are bigger now, bigger than angle 6. Well, angle 6 is right here. That's an interior angle, so certainly angle 8 is going to be bigger than 6 because that is an exterior angle, so angle 8 would be 1. And looking around, measure of angle 3 is also an exterior angle to that triangle, so angle 3 is also bigger than angle 6, guaranteed. Okay? The other thing we need to think about is the angle side relationship in triangles. We've already talked about this, that the biggest angle is opposite the biggest side, and the littlest angle is opposite the littlest side. Okay, that's one of our properties of triangles. So list all the angles in order from greatest to smallest here. Okay, well, our biggest side is right here, RQ. Our second biggest side is PQ, and our third biggest side is PR. So in order, actually from largest to smallest is going to be angle Q, that's opposite the smallest side, is less than. Angle next would be angle R, and that's less than the next angle, which is angle P. List the sides in order from shortest to longest. Well, looking right here, our missing angle, 45 plus 56, is 101. So this must be a measure of 79. It's our biggest angle. So our shortest side is going to be opposite the smallest angle, which is FH. FH is less than the second biggest side is FG, and that's going to be less than our biggest side, which is GH, opposite our biggest angle. Okay, moving on to 5-5. Here we go. The triangle inequality theorem says that any two sides of a triangle must be bigger than the third side. So, just looking at these two two problems right here. Again, we talked about this before. We used to write A plus B is bigger than C, where C is always my biggest side of the triangle. But really, any two sides of a triangle will always add up to be more than the third side. Is it possible to form a triangle with the given side lengths? If not, explain why not. Well, in this first one, we have 8, the two smallest sides is 8 plus 15, which equals 23. 23 is bigger than 17, so therefore, yes, we can make a triangle out of these pieces. In the second problem, our two smallest sides are 6 plus 8. 6 plus 8 is equal to 14, which now equals the third side, 14. So, no, we cannot make a triangle out of that because 6 plus 8 needs to be greater than 14, not just equal. So looking at this slide right here, when the lengths of two sides of a triangle are known, the third side can be any length in the range and be any length in a range of values. You can use the triangle inequality theorem to figure out this range. Well, looking at the first one here, we have sides of 3 plus 5. Okay. I know that 3 plus 5 is equal to 8, so my third side has got to be less than 8. Okay. I also now can look at this, how small can this side be? I need to get a number where my third side, let's call it x, is going to be in between. What's this, the smallest that I can go here? Well, if I have a side of 3, we can see now that 3 plus 3, 6 is bigger than 5. But how about if I go 2? What if that smallest side is 2? Well, 2 plus 3 is equal to 5, so I must be bigger than 2. The quick way to find this out is to say that x has got to be less than the sum of those two sides and bigger than the difference of those two sides. So why don't you guys try this problem right here. If the measures of two sides of a triangle are 3 and 7 feet, which is the least possible whole number value for the third side? I'll give you another second here. Well, let's just figure out the total range. I know that 3 plus 7 is equal to 10, so 10 is the max for my range. I also know that 7 minus 3 is 4, so 4 is the minimum of my range. So x has got to be in between 4 and 10. It looks like my answer here is, if the measures of two sides of a triangle, 3 certainly does not work. 10 would not work too. That's too big. It asks for the least. Would 4 work? No. X must be bigger than 4, so 4 does not work, and my correct answer is C, 5. Which of the following could not be a value of n? I'll give you a second. Okay, the correct answer is J, and let's figure out why. Why can't n be J? Well, 13 plus 9 is 22, so 22 is the maximum, bigger than what n can be. And 13 minus 9 is 4, so 4 is the minimum that n can be, or actually it's just less than the minimum. N has got to be bigger than 4 and less than 22. And all of these other answers work, but not J, 22. Let's review quick. The properties of our triangles. First, the sum of the angles is equal to 180. We know that. The sum of two sides is always greater than the third side. That was our new lesson today. A plus B is bigger than C. And thirdly, also from today, the largest side of an angle is opposite the largest side, and the shortest side, of course, is opposite shortest sides. And we know from the base angle theorem, equal angles are opposite equal sides. Hey, have a great day. We'll see you tomorrow.